everyone, and thanks for joining us for a fast chat hosted by wardsauto.com. I am Maite Bezerra. I am a principal analyst in software-defined vehicles for Wards, and I'm joined today by Jeff Kelly, who is a director of Vehicle Gateway and Connectivity and Vehicle User Experience at Infineon Technologies, with over 30 years of experience in automotive design and chip development. Jeff, thank you for joining me today.
Thanks for having me. Looking forward to our chat.
Me too. So today we'll be talking about how zonal architectures are unlocking future automotive EE designs. Let's get started. So, Jeff, how has the electric and electronic architecture changed from a few years ago to now, and what can we expect in the future?
Wow, great question. The vehicle architectures have changed over the past few years, and we're moving away from systems which tend to be a single electronic control unit, or ECU, and one set of fixed functions. Think something like engine control or braking and their associated hardware and software designs. Previously, an OEM would write a specification, have that box built to a set of requirements, and it operates in this fashion throughout the vehicle's life cycle. This type of architecture can be found in domain architectures, which are pretty common on today's vehicles. They tend to be the larger functions like body and convenience, powertrain, chassis, which means steering, braking, suspension, safety, and ADAS. These systems are well designed, reliable, but are purpose-built and difficult to use across many vehicle lines or add features to in the future when an OEM performs a market study or learns of something new its customer base wants. Today, Infineon is engaged in new EE architectures that are zonal in nature, which means they support new functions and handle their activity in a geographic region inside the vehicle. Software becomes hardware agnostic, which means that it does not need to know the compute platform on which it runs, and software updates really flow easily and steadily from an OEM right to all their vehicles. An easy way to think of zones is a front, a rear, a left, and a right that handle the local electrical features. The ADAS systems tend to stay outside of zones today as they need very low latency. So often they are still function defined to achieve the necessary performance and cost ratio. Today, OEMs have a strong shift in favor of zonal architectures with central computing systems and clean updates and feature additions. It brings to life that a vehicle will launch as a beta and improves month by month, adding new software, new features as they're imagined by the OEM and their customers, and supporting these new vehicles in a broader way.
That's very interesting. And one question that comes to mind is, why is this change in the EE architecture necessary? Why does it have to evolve?
A key reason for the change is a desire to serve the automotive customers better, add features and functions easily, and shift the vehicle design to support an open application environment, kind of like what you see in a cellular space where you can build apps specifically for that platform. Key value drivers that I would identify are reduce the number of boxes or ECUs. Many cars today have over 60 boxes of electronics inside them. They're trying to reduce this down to about 30. They would also like that these get reused across cars. In other words, what's used on your trucks could also be used potentially on sedans or other sport utility vehicles. They're going to remove fuses. They're going to replace them with resettable options that both protect the motors and the sensors and any downstream pieces. Remove relays and electromechanical solutions with pieces that are fully diagnosable, like smart power switches. Reduce and minimize software complexity, perform updates easily in the zones, the central computes, all the way to edge nodes, and simplify the wire harness design and its installation, reducing weight and cost to the vehicle. OEMs now have teams that will keep improving convenience features, lighting systems, driving dynamics, braking, bug fixes, and offer new and compelling services to differentiate their vehicles from that of their competitors. In a sense, it's a transition of the vehicle from the classic car we've grown up with to a mobile phone on wheels with transferable ownership rights, keys, and features and additions, maintenance via software instead of trips to the mechanic. It's kind of a new way of doing things, and it's to improve what the customers experience and what they enjoy about their vehicles. And I have to admit, I like the personalization one the best, that you walk up and the car greets you with some type of greeting functions and activities and knows which driver it is and sets itself up appropriately for that individual.
That is really cool. And I wonder, how do you see the OEMs being involved in pushing this transition or this change forward?
Oh, that's a fantastic question. It's almost easier to answer, how are they not involved? Because the OEMs are really the ones that are reworking how they want to design and develop their vehicles. As Vic Patel stated in a fast chat on the OEM landscape and software-defined vehicles, OEMs now begin their electrical architecture engineering process with a simulation environment where they can decide on their powertrains, whether it's electric or internal combustion, add or subtract performance and personalization features, size batteries, engines, and so forth. Once they've all the necessary virtualizations in place, they start putting their simulated vehicle through road environment models to gain simulated miles. If done well, this gives the hardware and software a rigorous set of use cases and improves the design. This extends all the way to partitioning of what features belong in which zone and how much compute performance is best to hit the cost and capabilities targets for the vehicle's full life cycle. So virtualization helps to set the full vehicle electrical design, thermal management, safety envelopes, removing of bugs, design flaws, and lowers production costs long before prototypes are ever built. It also will yield auto-coded software that can immediately be deployed on microcontrollers, which were purpose-built to support the coming vehicle. It's a rather huge change and brings the semiconductor selection into the hands of the OEM for whatever it identifies as the critical aspects that it wants to own and control. So examples of this would be SoCs, or systems on a chip, microcontrollers, microprocessors, memories, Ethernet switches, intelligent power devices, sensors, cameras. This environment allows zonal architectures to be iterated and carefully examined before committing them to the road. This is a complete flip of today's design process, where software is often one of the last items brought into the vehicle's lifecycle.
That is true. And I assume this is affecting the supply chain. So how do you see the supply chain ecosystem changing with the software-defined vehicles and this change in the vehicle EE architecture?
Oh, that's another fantastic question. You heard me describe what the OEM is doing and how it's changed. This obviously touches the supply chain as well. So they're going to change the supply chain and associated ecosystem for Zonal, and where it becomes a full platform. The OEMs will be able to interact with their vehicle customers, their full supply base, new application partners, in other words, people building things for them that will live and work within this environment, and their dealers and the repair network. It touches everyone. There's literally no part of the vehicle process that will not experience change with the advent of zones and these new architectures. So let me just tick off a few of the quick items from the new value chain. So OEMs add and delete functions via software and can sell new features to existing customers. A huge change in their business model. They often have been single-digit margins on their return, and I'm sure their shareholders want more. These platforms will offer a path to achieve that. Zones support new partner ecosystems environments, and this, I mentioned earlier, the apps and actually creating things just for cars. So instead of just phones or a computer or a tablet, there will be a whole ecosystem for cars. OEMs engineer the electronics hardware and software in-house and own the supply chain, allowing them to feature differentiate and offer unique selling points. One of the challenges they face now is if they choose to bring a car in with the feature set, and let's say the car isn't selling well because a competitor has added things, they not only can address what the competitor has added through those software updates, they can also add new features that they thought of themselves to outcompete the others in the space. So OEMs create new service models for future revenue streams and connect better with their owners to improve satisfaction. New zonal architectures can support plug-and-play hardware additions, including aftermarket. In the past, they would always push aftermarket away and try to keep that as a very minimal piece of the model, but they're realizing that there's value in bringing that in because there's some utility and ideation that takes place in that space that's very different from how you manufacture a car, and they want to encourage and pull that in as well. So maybe I just kind of wind it down a little bit and mention that if you do me a favor and keep an eye out, we're going to have a next session from Chris Tebow. He's going to talk a little bit more with you on partners and virtualization. And Mighty, I wanted to say thank you to you for sitting and chatting with me today. It's been a pleasure. And I have to admit, it's an extremely fun and exciting time in the auto industry right now.
Fantastic. Jeff, it has been a great conversation. Thank you so much for your time today and for these great insights. And I hope you all enjoyed the discussion with Infineon Technologies about how zonal architectures are unlocking future automotive EE designs. Thank you all for watching.